Today we're solving multi-step inequalities, and in order to solve a multi-step inequality, you first want to simplify each side of your inequality if possible. So things that you might do to simplify are use the distributive property or combine like terms. Then you want to use inverse operations in order to isolate your variable. When you're doing so, don't forget, if you multiply or divide both sides of your inequality by the same negative number, you're also going to have to reverse your inequality symbol in your solution. So let's take a look at some examples. So here we've got 2v minus 4 is greater than or equal to 8. In order to solve this, I first added 4 to each side, which gave me 2v is greater than or equal to 12. Then I divided by 2. 2 is positive, so I don't have to worry about reversing my inequality symbol. And my solution is v is greater than or equal to 6. So on my graph, I did a closed circle at 6 because v can be 6. 6 would be greater than or equal to 6. I also want numbers that are greater than 6, like 7 and 8 to fill in for v to make this inequality true. So I highlighted on my graph to the right. Let's try this one together. Y divided by negative 6 plus 7 is less than 9. So to start us off, I'm going to subtract each side by 7, and I'm left with y divided by negative 6 is less than 2. Now to isolate y, I'm going to multiply each side by negative 6, and since I'm multiplying by a negative, I'm going to have to remember that in my solution, I want to reverse my inequality symbol. So I flip this symbol. When I'm making my graph, I want to make sure to put an open circle at negative 12 because y cannot be equal to negative 12. There's no equal here. Y can be things that are larger than negative 12. So I want things like negative 11, negative 10, and so on. So I'm going to highlight on my graph to the right. I'll also come across inequalities where I have variables on both sides. Like here I've got an x on both sides. I've got 6x minus 5 is less than 2x plus 11. To solve this, I subtracted 2x from each side, which left me with 4x minus 5 is less than 11. Added 5 to each side, which gave me 4x is less than 16, and divided by positive 4, so my final solution is x is less than 4. On my graph, I put an open circle at 4 because x cannot be equal to 4, and I highlighted going to the left because values like 3 and 2 make that inequality true. So let's try solving this one together. So the first thing I'm going to do is distribute here in order to simplify this side of my inequality. So I get 6a minus 3 is greater than or equal to 10a minus 11. Next thing I'm going to do is subtract 6a from each side. So I'm left here with negative 3 is greater than or equal to 4a minus 11. For my next step, I'm going to add 11 to each side, and I'm going to be left with 8 is greater than or equal to 4a, and my final step is to divide each side by 4. And so my final answer is 2 is greater than or equal to a. So on my number line, I'm going to place my 2, and I'm going to put a closed circle at 2 because a can be equal to 2. And I'm going to highlight to the left because I want values like 1 or 0 in order to make this inequality true. A has to be something smaller than 2, so I highlight to the left. We also have some inequalities that will end up with special solutions. So in this one, 8b minus 3 is greater than 4 times the quantity 2b plus 3. I've distributed to simplify this side. Then I've subtracted 8b from each side, and I end up with negative 3 is greater than 12, which we know is not true. If this happens, this inequality has no solution. Let's try this one together. So I'm going to simplify once again by distributing on this first side. I'm going to get 10w minus 2 is less than or equal to 7 plus 10w. The next thing I'm going to do here is subtract 10w from each side, and I'm left with negative 2 is less than or equal to 7. In this case, this statement is always true, which means that for w, I can have any real number as my solution.